we had a couple of questions on test problems. One of the test problems provided the graph of some function with a scale on the graph, scale of 10 here, saying 20 here. Implicitly this is x here and this is your f of x. So we have an f of x versus x graph. And we want to know two things. What is f of x when x equals 4? And what is x when f of x is 12? For what x does f of x equal 12? Now if we interpret these questions carefully, it's not very difficult to get the answers. Okay, when x equals 4, what is f of x? Well, x equals 4 clearly is going to occur on the x-axis at this point. So we start with x equals 4 and we project up to the graph and we find the graph point that corresponds to x equals 4, and then we ask what is f of x? Well, f of x is just the y-coordinate, it's how far we went up. We can get that by projecting over to the graph, and it looks like f of x might be about 20 at that point, the x equals 4 point. Okay, so that one's fairly easy to find. And then the x for which f of x is 12. Now this is a little bit more complicated. You have to think a little bit more to interpret this. But notice that we're saying f of x is 12. What does that mean? That means that f of x, which is measured along the vertical axis, has to be 12. Well, f of x is 12 at this point, or at some point horizontally across from it. In other words, f of x equals 12 has to occur along this horizontal line. Because all along this line, your y-coordinate, which represents f of x, is 12. So we just go along this horizontal line until we encounter the graph. The first graph point we encounter for which f of x is 12 is this one. And then we just go down to the x-axis and see what that x value should be. Now we might have further encounters. It looks like maybe we slightly miss the graph here, but the graph might curve upward again at some point, and we might have more points where f of x equals 12. So there might be several answers to this on a given graph. There's only one answer to where x equals 4, to the value of f where x equals 4 if f is a function, because functions, as we know, have just one value at any x value. Another test problem involved a function, and let's zoom in on this a little bit, y, which is the thickness of a balloon skin as a function of volume. And we were asked what is the average rate at which skin thickness changes between volume 1 and volume 2. Well, to interpret that question, and this is nothing but a question on function notation, we should make a graph. Now this is a fairly realistic graph, or at least it shows that the skin thickness decreases as the volume increases. So we go from volume 1 to volume 2. We have a skin thickness at volume 1 that we can get by going up to the graph and moving over here. We got skin thickness at volume 1. At volume 2 we have another skin thickness, which is skin thickness at volume 2. These volume and skin thickness words are abbreviated just so we can get them all on a graph. We have a point then on the graph, volume 1, skin thickness of volume 1, another point, volume 2, skin thickness of volume 2. To find the average rate at which the skin thickness changes with respect to volume between these two, well, between the two volumes, we find the average slope between these 2 points. The run between the 2 points is the difference in volumes, volume 2 minus volume 1. The rise is skin thickness of volume 2 minus skin thickness of volume 1. So we summarize these ideas here. And we see that the slope is going to be the rise divided by the run, or skin thickness of volume 2 minus skin thickness of volume 1 divided by volume 2 minus volume 1. And this is the result we're looking for. This problem is a test of whether you know what an average rate is, and also of whether you can use function notation to represent these sorts of things, even when you have a fairly complex looking word describing a function. Okay, this is perfectly legitimate especially with computer algebra devices. We can give sensible names to functions and volumes. We don't have to have f of x or f of t or f of v.